City Mountains by John Parker. Steel and elevators. In the middle of the 19th century, two inventions made the building of skyscrapers possible. The first was the discovery by Henry Bessemer of a way to produce steel from iron on a large scale. Known as the Bessemer process, steel is made by forcing air through molten iron in a very hot furnace. Steel is lighter and stronger than iron and ideal for making skyscrapers. The second invention was made by Elisha Otis. He invented the elevator or lift. Elevators made it easier for people to work in the top stories of high buildings. Nobody wanted to climb stairs all the way to the top of a building many stories high. With the use of the Otis elevator, they no longer needed to. Now skyscrapers have many lift systems as well as escalators, moving stairways, to move people quickly and safely. Planning a skyscraper. Many people work together to build a skyscraper. Architects make plans and models of the skyscraper. They also make hundreds of drawings for every part of the building. They test the model in a wind tunnel to see if the skyscraper will remain strong and safe in high winds, and to ensure that it will not create strong winds at street level. Architects and engineers need to know the weight of the empty building. This is called the dead weight. They also need to know the weight of the building with everything in it, the furnishings, equipment, and people who will use it. This is called the live load. To make sure the skyscraper is strong and safe, engineers test the strength of the ground on the site. Then they and the architects decide how strong the base of the skyscraper has to be. Above the ground. The part of the skyscraper above the ground, called the superstructure, is built on the foundations. The superstructure has a skeleton or framework, usually made of steel. The framework consists of uprights, vertical columns, and girders, beams that run horizontally. The 102 stories of the famous Empire State Building were built on a framework of columns and girders. The framework also has diagonal bracing. This keeps the skyscraper safe and strong against earthquake and wind load. Wind load is the weight of the building when wind blows against it.